Guys, welcome back. So if you have made it here to this video, then you are getting ready to embark on our assignment for the week, which is a web quest about the scale of the universe. Now, this web quest has 5 different parts that are going to help walk you through just kind of thinking about the size and scale of our universe. In every part of this lesson, you'll see, well, I guess for every part of the lesson where there's something for you to watch or whether there is something for you to do, there will be a little orange button that you'll be looking for that says click here. And that will take you again so for some of these things, it'll take you to a video clip where you'll watch the video and then answer some questions about the video. For some of these links, it'll take you to a simulation where you'll be getting to go through some different simulations and answer questions. So basically then the last part, part 6, is going to be some summary questions, and there's nothing for you to go and watch or a link, but you're just going to go back through your document and look through the information that you've already filled out to answer those questions. So the first page is going to start you here with task 1, and it's just an introduction about the basically kind of the scale of the universe and like what are the largest things and what are the smallest things. And so just to kind of this is basically just reading. And then once you get into task 2, you'll start to see these links that you're going to click into. Your document has little boxes for you to type in, so that all that stuff is already set up for you. And so basically, as you go through these pages, by the time you get to the end, this is what the last task is going to look like. And so it'll basically just be a summary of the information that you've gone through. And then I'm going to ask you, this is your choice down here in this box, to write 3 fun facts that you learned about the size of the universe this week. And then if you have any questions or there are things that you still need help on, then give me that information there. And then I will try to go back and get your questions answered. So going back to this first page, this first question is just an introduction. And so it's saying that what is the smallest object that you can imagine? So there's no right or wrong answer here, but just think about what's the smallest thing that you can possibly think of. And then also think about what is the largest thing that you can possibly think of. And it says that it's hard to imagine how small and how immensely large objects in our universe can be. And I feel that that is really true. Take a guess. How long of time would it take for you to count to 1 million? The answer is about 2 weeks. Now try guessing this. How long would it take you to count to 1 billion? It may surprise you to find that it could take approximately 30 whole years to count to 1 billion. That's the power of the powers of 10. Adding a power of 10 to any single number exponentially increases or decreases it 10 times. Powers of 10 can be applied to any measurements, be it time, size, or distance. Powers of 10 are used for numbers that are too big or too small to write out. They use exponents to express this. For example, 10 to the power of 1 is equal to 10. Think about 10 times 1 is 10. 10 to the power of 2 is 100. So again, thinking about 10 times 2 is 100. And 10 to the 6th, or 10 to the power of 6, is 1 million. Now, why are we starting out by looking at powers of 10? Well, if we want to look at things that are really, really big or really, really small, then again, we're going to start dealing with numbers that are just too big to write out. And so, if we're starting here at 1, then if we go up to 1 power of 10, that's 10. Power of 2 is 100. If we go up to, like they said in the article, 10 to the power of 6 or 10 is 1 million. 10 to the power of 9 is 1 billion. So rather than going through and having to write all of these zeros out, we use these exponents. And this is equally handy when we start to get into really, really small things. And so when we start to talk about nanometers, that's really, really tiny. And so that's down here, with this 1 billionth, 1 billionth of, whatever it is. It can be like a meter. So really, really tiny. So the first thing that it's going to have you do is go in, and I believe that this is a video, and this kind of goes further into this idea of powers of 10 and things at really big scales and really small scales. So you've got it from here. Go ahead and try this out. For my online students, we're going to be going over this stuff in our weekly meeting on Monday, so please attend that. You get links bucks for participation, and love to do that. And then for you guys in the hybrid classes, we're going to start this in class, and we'll be able to talk about it while we're together. And then if you don't get this finished in class, you'll have time to finish it at home. If you're watching this and you're a hybrid student, it is okay to start this before you come to class. That's totally fine too. And especially for you guys that don't have science until Tuesday, I would probably recommend it just so you have less on your plate after class. So that's it for me. Let me know if you have any questions, and I'll talk to you again soon. Bye.